Welcome to this quickie about Too Heavy for the Chevy, slim down Java Docker images using Jlink. So first of all, who's using JDK 8 here in the room in production? That's very good. So I hope nobody's using JDK 6 or 7, because this only works if you have JDK 9 at least. Okay? So who's using JDK 11 here? 17? Oh, nice. 21? Okay, cool. So that works. So my name is Gerrit Grunwald. I'm working for Azul. We do JVMs and everything what's related to Java. And the question is Java too heavy when we talk about containers, so Docker images and specifically? Well, depends, right? Because first of all, I have an example app, and you can check it out. It's on GitHub. You will find it here. It's pretty simple, just a name service. It's a Spring Boot application. It has just one REST endpoint, and it returns random names for boys and girls. That's it. This is just to, if you would like to play around with this stuff, there you will find also the Docker files that I will show you. So the problem is, if we take a look at the JDK, and then I have to ask you, who is deploying a JDK in a Docker container here? I hope there is a really good reason to do that. Because you don't have to, right? Because when we do that, and we take a JDK, after JDK 9, and this is the number of modules in the JDK. You don't have to read it. It's, if my clicker works, it doesn't. Now nothing works anymore. Oh. Okay, give me a second. What's going on? My system crashed. I have to reboot the machine, sorry. I don't know what's going on. I didn't use NetBeans, so I can't shut it down. What is that? Hello. Okay. Oh, okay. Okay. We have to speed up. I don't know what it is. That never happened to me. Nevertheless, so we saw already we have JDK. It has lots of modules. That was 69 modules if you have a JDK, which is around 380 megabytes, if I'm right, or maybe 340. We will see the right number. But this is the amount of memory that you have if you deploy with the JDK, just for the JDK. The service that we saw, okay, is around 24 megabytes. Spring Boot is known to be not really small. Say it like that. Okay, so hopefully my system will come back. Okay, so that means you deploy a JDK in your container, you blow up the container just because you add the JDK with its 69 modules. And come on, yep. Open. Give me a second. Here we go. And fast forward. Check, check, check. Here we go. Okay. So we have 69 modules, and what is going on here? Okay, I'm always one slide behind. I don't know what's going on. So we have 69 modules, and it's 338 megabytes for the JDK. And now if we put that in a Docker image and we use, for example, Ubuntu for that, who's doing that? Someone using Ubuntu for Docker images here? Yeah, why not, right? So let's take a look at the Docker file. This is how it looks like. So we take from Ubuntu latest, and we build it, and then we use, this is Azul JDK that I use here, JDK 17.011, and then we create our application file is here, the name service jar, and then when we create the Docker image and check it out, then this is the size of the Docker image, 638 megabytes. And you see Ubuntu is 78 megabytes. Then there is an additional layer added here of 200 megs. The JDK 338, and the application is 24 megabytes. To run the very simplest REST service, I blew up my image to 640 megabytes roughly, just because I was lazy. And then the people from the CI/CD team, from the deployment team, they are really complaining, oh, the Java stuff is so big. It takes forever to download the images. Yes, it does. If we take a look at the JRE, who's using a JRE for Docker images? Yeah, that's better. But still, as you can see, still 50 modules. Still 142 megabytes, right? So for these people here in the room that use a JDK, this is the first step you should do. Go to a JRE. This is a runtime environment. You don't need the Java C compiler and all this stuff in your Docker container, right? So use a JRE, it's made for that. So we go again with the same thing. We use Ubuntu, and, oh, this is, by the way, wrong. It's not updated. It's 17.0.11. Take a look at the Docker file. Very much the same. As we can see now, in the middle, I download the JRE, the Java runtime environment. And then if we take a look at the size, this is now 290 megabytes. That's way better, right? That's at least half of it from the size. You see again, Ubuntu, 78 megabytes. The additional layer now is smaller, 74. JRE is just 142 megabytes. This is still, I mean, 300 megabytes for a REST service that has one endpoint and gives me some names. It's huge, isn't it? I mean, I remember the days, I'm a little bit older, when we count program size in kilobytes. When I just think about just to run this shit for 290 megabytes, it's just too big. Yeah, it's not needed. So do we have any alternatives here? Did someone ever heard about this JEP? Yeah? Modular runtime images. And we have this stuff since JDK 9. And just as a reminder, we are heading to JDK 23. So it's not really new, right? So this is available for a long time. And it contains apps and platform-specific modules, right? So this is the idea behind this JEP, to create a runtime image that is tailored to your application, right? To slim it down. With JDK 9, the idea of the whole modular JDK was not really to make it harder for you guys, but to slim down the JDK, because you don't need all the modules for your application. Question is how to create a custom runtime. Well, there is another JEP, JEP 282, which is for the Jlink tool, right? Did someone ever heard about the Jlink tool? Yeah, you know, probably. But the others? That was presented when JDK 9 came out. But somehow people didn't realize that it's really beneficial. So this is a tool. It comes with the JDK. You don't have to download. It's part of OpenJDK. It can assemble and optimize a set of modules and their dependencies into a custom runtime image. It's exactly made for this problem, right? And it comes with some command line flags. As we can see here, the compress is deprecated but still works. The important part is the list of JDK modules. You add the modules that you would like to use in your custom runtime. That's the idea. The question is how to get the modules, right? How do I know which modules are used by my application? Well, there is another tool which is called jdeps. Came at the same time. It's also part of OpenJDK, so you have it on your machine. If you type it in and you have Java home set, it will give you an idea what it is. It shows package level or class level dependencies of a Java class file. That's the idea behind jdeps. So that means you use jdeps, run it on your class files to get an idea which modules are used, and then the output from jdeps you can use in Jlink. These are the command line flags. It's not really a lot. The important part is the class path stuff here with the app jar and the libs folder in this case. And the result could be, for example, something like this. You get a comma-separated list of the modules that will be used by this application. That's the idea. Pretty simple, right? And it's really simple. It's not really a lot of work to do that. And if we now, and then it's what it would look like. If you create Jlink with the output from jdeps, you put the add modules, you just put the string there. That's the whole thing. And then it will more or less copy from your JDK folder these specific modules in a specific folder, and that's the custom runtime. This is one thing we can do. We can use Jlink, but instead of using Ubuntu, we can use Alpine Linux. Is someone using that already here? Very good, because we will see the difference there. So to do that, we have to unpack the Spring Boot fat jar. for example, in this build unpacked folder here, we run the jdeps tool against that. This is how it looks like, right? So I pointed to the lib folder and the jar file, and then it gives me this number of modules. So that means for my application, I need these modules to run it, right? I don't need Corba and other stuff, right? Well, which is not even in the JDK anymore. But if you deploy with the JDK, you give it all the options. Even in the JRE, you give it all the options, even if you don't use it. And that's also a security issue. Because if you just add the modules that you use, you don't open the doors. But it might be that there is a CVE open, so a security issue in one of these modules. But if you don't have it, then it can't be attacked. So in this example, for the Spring Boot app, it was 14 modules that I use, instead of the hundreds that we saw before, and it was 40 or 60. So we copy the result to the Docker file from the output. So that means this is our Docker file right now. So we copy the Jlink stuff in the Docker file, right? So you can do that when creating the Docker image, you can do that automatically here. You see there is the Jlink path with all the modules that we use. And then we build the stuff. That's not really magic. And then we end up with 96 megabytes, which is way better than 290, right? It's all for the same stuff. And you see Alpine Linux is just 7.3 megabytes instead of Ubuntu with 78, I think. So if it's really about running these kind of things, and if we talk about microservices, this makes sense, because usually you should have microservices, not macroservices. So that means they are probably small. Why giving it the whole Ubuntu, the whole JDK, if you just need this tiny part of it, right? And people from the ops team will be happy if you can tell them, oh, we stripped down the Docker images from 680 megabytes to 96, right? So if we compare the images then, going from the JDK with 70 modules on Ubuntu from 638 megabytes down to JRE, that was already a reduction of 54% here. And we still use 50 modules. We only need 14. So if we go further down to 14 modules and using Alpine Linux, this is a reduction of 85%. And now I ask you, why don't you use that? Because this is available for years, but nobody's using it. I don't know why. I had a session last week at the Java user group in Bordeaux, and one of the guys tried it. Over the weekend, or on Monday, he pinged me. I was able to reduce the Docker image by 120 megabytes just because of that. So it's really easy to reduce the stuff. And if you go to the GitHub repository that I showed you, you will find the Docker files there and how to use it. So it's not really hard. And if you're interested in how I figured out the size of the Docker images and all this stuff, there is a tool called Dive tool, right? So you can find it here. And that's a tool specifically made for exploring Docker images, layer content, so that because they are layered, right? But it's hard to figure out what is the size of all these layers and what is it. So this is a tool to get the information. That will help you to strip down your images. Even if you're already using Jlink, sometimes you can reduce it more by removing stuff. And in principle, that's already it, because it's not really a lot of stuff to cover. So if you have questions, we still have, I think, if this is right, 7 minutes for questions. Yes? Yes. So the question was if Jlink also takes the dependency modules and all that, and it does. So it will figure out all that. So this is, like I said, this tool is made for creating custom runtime images. And so I have no idea why people don't use it, because when JDK 9 came out, there was a lot of noise about Jlink and all these modular runtimes, but unfortunately, it looks like people have been so messed up with this, oh, I have to do modules, and you don't have to. Your application doesn't have to be modular to use Jlink, right? This is only the JDK. So your application can be one huge class path, fat jar, whatever, and you still can use a custom runtime for this jar. That's no problem. And my advice is just take at least a look at it, because it will really improve the loading time of your images a lot. And who's working with microservices here? There you go. Jlink. Yes, a question.
What about modules which are loaded not statically, but with reflection and all these kind of things? Because I recall once that something happened to me, like I was using this and then everything broke.
So you mean if you have a project that uses reflection to look up stuff, but then still should be in the dependencies, right?
It was something with the Spring.
I mean, this is a Spring Boot application, and we all know that Spring Boot uses a lot of this reflection stuff. And this was, I'm not a Spring Boot expert. I just took this stuff and ran it. And if this wouldn't be covered, it would be a bad tool, I guess. So I never ran into problems with using Jlink and jdeps. Like I said, jdeps is also, these are the two tools you need. jdeps is to figure out all the modules, and then you can even do it in one script. You can use the output from jdeps directly in Jlink, and then you have, I think I even have shell scripts there that do the whole thing in one step. It's just an additional step in your build scripts, and then you can create these custom runtimes. And the other advantage is, if you include it in your CI/CD build, then because sometimes you add some dependencies or you add new modules, right? So you can't really make sure that you created this stuff once and it will work forever. So it's a good idea to have that as part of your build process. And it won't take a lot longer, because what it usually does, it takes a JDK, figures out the modules that you use, and copies the used modules in a new folder, and then this will be the new custom JDK or JRE. That's the idea behind it. So even with reflection, should be no problem. More questions? Yeah, over there.
Hello, thank you for the presentation. I was wondering, have you ever tried to use another tool than a Docker file, like zip, for instance, or any other tool for creating Docker images?
I didn't use it because this is now for Docker images, but in principle, this shouldn't be any difference, because whatever container service you use, right, if it's Docker or whatever format, you have always to copy your JDK, JRE, whatever, inside of this container. This is just to strip the runtime down, so reduce the file size, whatever you do with it. You can also just, if you don't even use a Docker container or whatever container, and just run it on a prem, for example, even then you can use the custom runtime, right? So it's just reducing the runtime size. That's the whole thing. And tailor it to your application. That's the main idea. And even, it's especially important when we talk about microservices, where you usually have services that just use very few things, right? And you start them up and you shut them down. Why deploying the whole JDK or JRE if you never use most of the stuff? It's just not needed at all. But yeah, like I said, always when I ask people, nobody's using it. I don't know why, but it's pretty simple. So you should really give it a try. Any more questions? Yeah.
Yeah, I have another one.
Yeah.
So you said that this should be in the build process, right? So basically integrated in the CI. And let's say we are a big company with more than 200 microservices, and we have a standardized way to do the CI.
Yeah.
In this case, each team or for each service, we would have to maintain this part.
You don't really have to maintain it, right? Because this is in principle one script part that you add. And always when you build it, it will figure out the modules that you need, create the image or the runtime and create the image from it. So you just have to set up the script once. And then there's no maintaining, because this is only in your final container. You don't keep the custom runtime somewhere. It's really just during the build process, it will be created, you copy it to the container, and then you're done. It's go away. So there is not really something where you have to keep track of all these runtimes for all the services. That's not needed. It's just a part of the build script if you build the container, usually you build the application, you just get the JDK, create the custom runtime, create the image out of it, and then deploy it. And this is just an automatic step that you can always use. And even if you change stuff, the script will figure out the new dependencies, will add the modules or remove modules, and then create the new runtime. But that also means the runtime might be different on each deployment, depending on what you change. Yes? But this is usually not a problem because you also don't care if there are new modules in the JDK, right, or in the JRE. You just deploy it. So this is
Okay, thank you.
okay. Still 1 minute. If there's one more question, then oh yeah, there's another one. Oh wait, he comes with a microphone.
Thank you. Does it also take into account the flags that we add when we launch the application? For instance, if I'm going to use the flight recorder or something like that.
This is no problem.
No, there's no issue with
No.
the, okay.
No, because, I mean, like I said, I mean, it could be a problem sometimes. There are reasons when you really need a JDK in production. This is when you do debugging.
Yeah,
you really do live
that was
debugging, but this is not always needed, right? So it's because most of the companies don't really use in production debugging, right? So this is very rare. You do that in a test system, or staging, but usually not in production. But then it could lead to problems sometimes. But then you will figure that out. So,
so I want to complete something to your question about using JDK tools. Usually the JDK tools, they are also in modules, like Gerrit has explained. And if you want to have a specific module, like using JFR and actually maybe connecting remote to do some JFR inspection, there is like JDK.management module, I think, that you need to use. Otherwise, remote connection would not function. So in case of tools, you kind of have to go by yourself and find the JDK module of the tool, because jdeps will not detect the tool itself. It only looks at the application that you're having, like your Spring Boot application.
and there's also talk from Anna Maria about that, right?
Thank
you
you,
have
yes.
a talk about JDK tools.
Yeah, but I didn't cover Jlink because not much change except for the compression level. So after JDK 17, the compression level for Jlink changed. It used to be 0, 1, 2. Like 0 means it was nothing, and 2 was zip, was the greatest compression level you can achieve. After 17, nowadays you have different compression levels, starting with zip 0 and going up to until zip 9. Zip 9 being the best compression you can achieve. Default level is zip 6 for compression of the. Also, compression matters in terms of sizing. So, yeah.
Okay,
Sorry.
and that's it. Thanks for attending.